bromination of phenol, it's a method for assaying the content of phenol. Without talking much, let us go into the calculation aspect of it. All right. Now, the question, you need to be given some parameter. The phenol, the molecular weight of phenol is 94.11 gram, and 94.11 gram per mole. However, you might not be given this 94.11 gram. You have to calculate it. Phenol is what? 66H5OH. Carbon is 12, so you say 12 times 6 plus hydrogen is 1 times 5. Oxygen is 16 plus hydrogen is what? 1. 12 times 6 is 72. 1 times 5 is 5. Then 16 plus 1. 72 plus 5 is 77. 77 plus 16 is 93. 93 plus 1 is 94, which is approximately 94 gram per mole. Is that okay? So that is how to calculate the molecular weight in case you are not given. This is the equation of reaction. Of course, phenol will react with 3 molecules of bromine, right, to give us bromomethane, right? Thought I did something like that. To give us bromophenol, rather, not bromomethane. Now, because this bromine is, I've made a video like this. Let's just leave it here. Because this OH is an auto-para director. Of course, bromine will be attached to the auto and the para position. Then plus 3Br. All right. Now that is that. Now I say assume that 0.5 grams. So the mass of phenol given is 0.5 gram mass given. Now you want to check if the mass actually given is 0.5 gram. If what is present, the content of phenol is 0.5 gram, was reacted with excess amount of 0.05 molar standard bromine. Now, because it is standard, you don't need to calculate for what is it called, factor. You don't need to calculate for factor, because I saw most of you calculating for factor. You don't need to calculate for factor. With excess amount of 0.05 molar standard bromine solution, 5 ml of corn KCl was added to the content, was repeatedly shaken for about 5 minutes and set aside. To this, 5 ml of all these, they are just this thing. Then a blank determination was also done without phenol. The blank determination, you have the titer value with phenol, and then blank determination. So you want to know the amount of phenol that reacted, amount of bromine that reacted with phenol. Now, to get the amount of bromine that reacted with phenol, which you are going to use as your titer volume, you substitute this 17.6 minus 10.50. So it will be 17.60 minus 10.50, and that will give us 7.1 ml. So the amount of bromine, which is our titer value that we are going to use to solve, will be 7.1 ml. Is that okay? Take note of all this. Say determine the milli equivalent of phenol. Now, from the equation, you can see that 94.1, which is the molecular mass, 94.11, or you can use 94.11 gram per mole, or 94.11 gram of phenol. Let me not write the phenol out. Write C6H5OH reacted with 3 mole of bromine. Now, this 3 mole of bromine, based on what we'll be doing on milli equivalent, we say this 3 mole can be written as what? 3000 millimeter, 1 molar solution of bromine. Are you getting it? But in the question, what they ask you is 0.05 molar standard bromine. So we must convert that 1 molar to 0.05 molar. And the reason why they call it milli equivalent is 1 ml of the standard sample given. 1 ml of the standard sample given. So we must convert this 3000 ml to 1 ml, convert this 1 molar to the molarity given, which is 0.05. And anything you do here, you do it here. Anything you do here to any of these ones, you must do it here. But at the same time, you must not do like divide 2 of them at the same time. If you divide 1 here, divide 1 here. divide this one, you divide this one, but you must not divide both of them at the same time. So we want to convert this 1 mole to 0.05 molar. First of all, what do you do? Divide by 2. So I'm also going to divide here by 2. And this will give us 47.055 gram of C6H5OH. That will give us 3000 ml. This cancel this, 0.5 molar bromine. All right. Now, at the end of the day, you are looking for 0.05 molar, not 0.5. So you have to divide this one by 10 again. So we are going to divide here by 10. When this cancel this, that will give us what? 4.7055 gram of C6H5OH will give us 3000 ml. When this divide this now, 0.05 molar bromine. Now, at the end of the day, this 3000 ml was converted to 1 ml. So divide here by 3000. Divide here by 3000. All right. Now, when you divide by 3000, when this one cancel this will give us 1 ml, 0.05 mole bromine. And when you divide this will give us 0.0015685 gram of C6H5OH. will give us this. My laptop battery is low. Will give us this. Is that okay? Now, at the end of the day, what do you think we can actually do? So this is your milli equivalent. So when they say the milli equivalent, this is the milli equivalent weight they are expecting you to use. Is that okay? That's the milli equivalent. We've already calculated the titer value to be what? To be 7.1 mil. All right. The next is calculate percentage weight by weight of this one. Now, the mass of phenol given, that is mass of phenol given for C6H5OH is equals to the mass. The mass given is 0.5 gram. Calculated mass. How do you get the calculated mass? Calculated mass is equals to milli equivalent times titer value. You don't need to multiply by factor. Why? Because they gave you standard bromine solution. You only calculate by factor if you are using a secondary standard. So our milli equivalent is 0.001568 gram times the titer value is this one when you subtract these two from each other, 7.1 mil. So that will give us 7.1. When you now calculated weight give us about 0.011 gram. Are you getting it? So percentage of phenol, weight by weight of phenol in this sample. Now this mass they give 0.5. Normally they are supposed to dissolve it in something and then from that they take a particular value for the titration. But they didn't state it. You understand? Normally, you're supposed to dissolve this 0.5 gram inside something. Then from that something, and that's where you now take. Then you do that calculation. But this one, it was not stated that it was done that way. So you do it like that because the percentage we are getting is very, very small because they didn't state to reduce this mass. So 0.5 gram times 100%. And the percentage will give us about 2.2% weight by weight. What I mean is, if you check your manual, they said, if you check your manual, the method for this particular practical, they said dissolve 0.5 gram of sample in 250 ml of water, measure 25 ml into 250 ml iodine flask. Are you getting it? So dissolve 0.5 gram into 250 ml of water, measure 25 ml. So 0.5 gram, normally, according to what is your manual, 0.5 gram is present in 250 ml. And then they now say measure 25 ml. So you are now going to say 25 ml will be equals to what? X to calculate the amount in 25 mil, which will be what? 250x is 0.5 times 25. So divide both sides by 250. This here, and then here will give us 0.05. So x is supposed to be 0.05. That's what I mean. Like what will be under here is supposed to be 0.05. But since they didn't tell you that it was dissolved in 250 mil before you take 25 mil out of it, you just solve with it. And that is why our percentage giving us a very low value of 2.2% weight by weight of phenol. So that is how to get that answer. And then my laptop is getting low. That is why I'm very fast, so that at least your exam is also very close. Why was concentrated ACL added? ACL was added to acidify the medium, enhance bromination, and ensure proper liberation of iodine for accurate titration. That is basically all for this lecture. Thank you very much for your time. We'll see you in the next one. Bye-bye.